Now finally moving on to question 4, this is the very last question for this exam here. And it's not too bad of a final question, it's just basically looking at a continuous uniform distribution here for part A, and then this second part here just involves a probability density function for a continuous random variable. So let's jump straight into this. So part A begins with the continuous uniform distribution. So part A, and it tells us that the variance of x is equal to 27 over 4, and we have to show that A is equal to 14. So A here is the part of the interval, so it's the upper limit of the interval. So what it's saying is that this limit here, or the interval, is 5, 14. And we've got to show that A actually is 14. Well, the only bit of information that they give us that would help us in this question is the fact that the variance of x is equal to 27 over 4. So because this is equal to 27 over 4, can we use this fact to get an answer for A? Well, the formula for the variance of a continuous uniform distribution is given in the formula book, so you don't have to worry about memorising this. And the formula is as follows, so it's 1 over 12 times b minus a squared. So that's what the formula is, 1 over 12 times b minus a all squared. But we know in this case that's equal to 27 over 4. And remember the a and b, that's your a and that's your b. Now I know obviously in this case they give a as this one here, but we just use a to indicate the lower limit of the interval, b to be the upper limit. So we plug these limits in and start simplifying this expression here. What will we get? So 1 over 12 times b minus a, where the b is a and then my a is 5 all squared, is equal to 27 over 4. Okay, let's keep simplifying. I'm going to times now by 12. So times both sides by 12, I'll just get a minus 5 all squared. This side here, 27 over 4 times it by 12, you'll get 81. Now we just need to carry on working this out for a. Well, the first thing I could do, I could just square root both sides. Just take into account obviously the fact that I could have the negative square root as well. So this is going to be a minus 5. It's going to be equal to 9, or a minus 5 will be equal to minus 9. But obviously we could have two potential a's here, but there's clearly an important fact here in the fact that the lower limit of the interval is already 5. So whatever my a is, it has to be bigger than 5. I can't be lower than the lower limit of the interval. That wouldn't make sense. So my a must be bigger than 5. Well, if you work this one out here, a would be equal to 9 plus 5, so a would be equal to 14. If you do the same here, it would be minus 9 plus 5, which would give you minus 4. So a would be equal to minus 4, but we can't have this, so a can't be equal to minus 4, as a is greater than 5. So therefore, we've shown that a is equal to 14, as easy as that. Okay, so that's part A. So we just clear this now because we're going to need more room for part B. So we're given this probability density function here, f of y. And it tells us that the random variable t is equal to 3 lots of x squared plus x plus 2y. And we have to show that e of t is equal to this quotient here. Now 7 marks. The trickiest bit about this is just being able to understand what you're being asked. So we've got this variable t here, and what it's doing is it's combining these two distributions. Well, what you've got is you've got your x squared and your x here, which are related to the continuous uniform distribution here. And then if I just change the colour, you've got your 2y here, which is related to your distribution here for the probability density function. So you've got to combine these now to be able to show that e of t is equal to this quotient. Well, if we start here now for part B, well, let's work out the uniform distribution ones first. They're a little bit easier. So if I work out the mean first, so that would just be e of x. Okay, so e of x, well, what would that be? Well, the formula for e of x, that's just going to be a plus b divided by 2. Okay, well, a plus b in this case is 5 plus 14 over 2, which gives us 19 over 2. Okay, so we've got now this x here. Now we need to work out x squared. So remember, e of x squared is related to the variance. So the variance formula, so var of x, that's equal to e of x squared minus mu, or e of x all squared. So doing that now, if I do it over, I'll do it over here. So e of x squared, well, we know the variance is 27 over 4, so that's that, 27 over 4, that's equal to e of x squared minus 19 over 2 squared. 19 over 2 squared. Plug this on your calculator now, so 27 over 4 is equal to e of x squared. This 19 over 2, that would be minus 361 over 4. So add this to the other side, so therefore what you get is that e of x squared, that's just simply equal to 97, okay? So we've got the x squared, we've got the x, now we need this 2 lots of y, so we need the expectation of y. Now this is the tricky bit, and it's in your formula book, so you don't have to memorise the formula for it, but we're going to have to integrate this now, so it's going to be the integral, and it's in your formula book, it's going to be the integral of y, f of y, dy, okay? So it's very important you've got this extra y that you multiply f of y by. If you forget this y, everything's going to fall apart. Okay, so that's going to be now the integral, and don't forget your limits. We're between 2 and 6. So my upper limit is 6, the lower limit is 2. So this is essentially going to be y over 20, because it's 1 over 20 here, times 2y minus 3 dy. Now it's up to you how much you simplify here, just to make life a little bit easier. You can even take the 1 over 20 outside. It's completely up to you. What I'm going to do first across is just multiply here. So I'm going to do y times 2y, y over 20 times 2y. So I'm going to get y squared over 10. Let's do the same again with the minus 3. So that gives you minus 3y over 20. So I'll just put my integral symbol in again. Obviously my limits are the same. I'll do little dots to indicate the idea. This is respect to y. So now we've just got to perform this integration. So if I do it in yellow, I can do this all the way at the top now. Okay, so we do this at the top. So performing this integration now, add 1 to the power, divide by the new power. So this bit here, add 1 to the power, divide by the new power, that'll be y cubed, and then divide it by 3, same as times it by 1 over 3, that'll be over 30. Add 1 to the power, divide by the new power, this would be minus 3y squared over 40, okay? And then don't forget my limits are 6 and 2. 6 and 2. So now all you've got to do is plug a 6 into here, and then do the same and subtract the 2 off here for the lower limit. So I've already done this on paper, but do it yourself, make sure you can actually get this. So you should get 4.5 minus, in the bracket, 4 over 15 minus 0.3. So if you simplify that, it's 4.5 minus 1 over 30, so plus 1 over 30. And then if you do that on your calculator, what you should get is 68 over 15. So that now is my y, so that's e of y. So we've got everything we need now. All we've got to do is finish the question, put everything together. So I've got 3 lots of x squared plus x. Well, my x squared is 97, my x is 19 over 2. So there's going to be 3 lots of x squared, 97, plus 19 over 2, plus 2 lots of y, where y is 68 over 15. Now all we've got to do is put this on the calculator. So there's going to be 3 lots. So that'll be 3 lots of 97 over plus 19 over 2. So do that and you get 319.5. And then do this bit, you get 136 over 15. Add them together, and then make sure you got it as a quotient. You'll get 9,857 over 30, as required for part B. So there we go, that's question 4 fully complete. So if you're new around here, guys, be sure to subscribe. I'm working through all the Edexcel further maths papers, barring mechanics and decision, because I don't really do much work with them. But if you find it helpful, be sure to subscribe, guys, and leave a like below.